First, I would like to thank organizer for providing this opportunity. I think this is the place where two ministries are working together, both Ministry of New and Renewable Energy and Ministry of Earth Sciences. Actually, National Institute of Ocean Technology comes under Ministry of Earth Sciences. We work on the ocean. You already had several questions whether it is feasible or not for that. In fact, when we started our first work in the offshore wind, this one of the first question asked is whether it is feasible commercially or not. But I think with the LiDAR which we are installing in Gujarat along with Neve, it is found to be feasible. Still I remember in the first instance when they asked what is the installation of LiDAR in the sea. I think still Dr. Katyal remembers in the beginning time, people were asking somewhere around 15 crores for the installation of LiDAR. But now I am confidently telling that I think we are putting up that LiDAR, excluding the LiDAR cost of the LiDAR, the installation cost is only 4 crores, not more than that. This shows we have a capabilities within the country, and then I am sure in the future, with after my presentation, you will understand that offshore wind is feasible compared to the other countries. Actually, we have a good manpower here, and then which is available at less cost compared to the Western countries. And also some of the techniques what we need to adopt for that, that will definitely bring the cost down further. I show some numbers on the costing and which we can further debate on that further. So my outline of presentation is, we have some introduction. I'll just skip some of the things which Dr. Katyal has already covered that. And present power scenario in India, wind energy in India, which I think MNR is the lead on that. We will be supporting only for the offshore component of that. And wind resource assessment, which is already mentioned that INCO is the base map for the wind resource assessment, and which is quite reasonably good that their own measurements confirms that whatever INCO has made the measurement, which matches with their own observation for that. Important part is the commercial viability, whether it is feasible or not. This is the standard question asked to us, offshore wind, whether it is feasible or not. To this stage, I think it is feasible, and then you will see from my presentation. And one of the challenging tasks for the offshore wind is, since we are working in the sea, you require a lot of investigations to be done, and data collection platforms have to be installed in a challenging environment. And what kind of substructure for offshore wind need to be installed, because this is only cost more than compared to the land for that. Some of the R&D efforts on India towards offshore wind and conclusions. We know very well about this carbon emissions. I think if in urban area, it is almost double what we generate the fossil fuel for that. Now right now entire population lives in the coast, and 1/4 is only carbon emissions from the rural area. Suppose all these people start expanding that, now we can see how much damage we are going to cause to the environment. That's why renewable energy plays a major role for that. This shows the present power scenario in India. We have almost 306 gigawatt. In fact, these numbers are taken from the standard reports of MNR and other places. As far as renewable energy is concerned, we have 44 gigawatt. But if right side, if you see the pie chart, coal contributes maximum, but whereas in the renewable energy it comes around 13.4%. Within the 13.4%, wind constitutes 8.6%, small hydel power plants 1.5%, and then bagasse oxygen, it is from the sugarcane, which comes for that. Of course, hydro also is the second place for that. The per capita, what we estimated from there is, I think it is all taken from there, 746 kilowatt hour for that. Renewable energy, it is a sustainable energy, source comes from natural environment. If you see some of the benefits of renewable energy, it exists perpetually and abundant in environment, ready to be harnessed, inexhaustible. It is clean and alternative to the fossil fuels. It can be derived from and then easily replenished. And one of the important factor which comes from the renewable energy is, so why we need to go for renewable energy is well talked about, whether it is a blue economy or some other place for that. In fact, one of the study by IIT Bombay shows very clearly that from the global climate model, the wind intensity has increased over a period of time. This shows a positive energy for that, how long run wind is going to be a beautiful source for that. In fact, Tamil Nadu, normally their power consumption is very high during the summer months. That particular month only, we have a good winds, and then it meets, I think, the major power requirement of Tamil Nadu only from the wind, especially during the summer season for that. When you look at the RE capacity renewable energy, wind again constitutes 58%, solar PV, which Katyal has already mentioned about that. Now that is the major thrust for that, but nevertheless, wind plays an important role for that. Country-wise, if you start seeing for that, we always used to compare with China. So you can see from the bottom, China is coming up with a huge plan of almost 114 gigawatt what they are planning, but India is only at 22.6. This shows a clear distinction how we have to catch up to the China, suppose if we want to do for the renewable energy. Similarly, solar PV, our role is also very low, and then we need to scale it up further. If you look at global wind, totally its capacity is around 370 gigawatt. India stands in 4th position. Solar, we stand in 11th position. These are all some of the statistics which shows where it is there. MNRE, as I think Dr. Katyala has already mentioned about that, set a huge targets for the future. On that, wind plays a major role. Next one is solar, and then other things comes at the next part for that. Coming to the onshore wind, this is from the NIVE only. Installed capacity is around 26.8 gigawatt. We have a huge potential of 49 gigawatt if it is at 50 meter height, and 102 gigawatt if it is at 80 meter height. If you start seeing about the map, I think Katyala has not presented this map. Tamil Nadu goes almost 7 gigawatt, but whereas next is Maharashtra, then Gujarat and Rajasthan, even Andhra and other places also equally good for the onshore wind. Coming to the cumulative wind capacity up to 2005, we don't have much increase, but whereas beyond 2005, it is exponential growth in the wind installation capacity. Of course, he has already mentioned about the many incentives are coming for the wind which need to be continued for the future. Coming to the offshore wind, he has already mentioned about it is less turbulent. One of the important for the offshore wind is there are strong and consistency. That's how the plant load factor compared to the land, it goes up. Normally the land plant load factor is around 0.25. Suppose if you go to the offshore, it ranges somewhere from 45 to 55. Then that shows the promising results for the offshore wind. So what we normally aim at is whatever the plant load factor which is there from the increase from the land to offshore, that much of cost straight away goes to the substructure and then evacuation further. That's how it is not a surprising thing that offshore wind is not feasible. It is feasible because of this good plant load factor for that. Coming to the evolution of the offshore wind, any of these kind of renewables, not only our country, all the countries got a lot of difficulties at the initial stages for that. Sweden got a first plant, but second wind plant in Denmark. Now if you look at current status in Europe, they almost have a 3 gigawatt, but they are almost having a planning of 63.5 gigawatt for that. When you come to the UK and then overall pie chart for that, UK stands first, Germany second, and Denmark third. But India is nowhere in that. Now we have to come up with the plan for that. Coming to the European scenario, if you start seeing for that right from 1992 to 2000, there is no wind farms in the offshore. 2000, they have picked up offshore wind, and then unfortunately in 2004, there is a drop in the wind hour. If you start looking at what is the reason for that, high construction cost, unexpected failures of extreme winds and waves. This is where NIOT plays a major role for that. We can make these things to be viable, suppose if you have a good understanding of. In fact, we have a few institutes in India who works on the ocean, Ministry of Earth Sciences and then National Institute of Oceanography. And then if this expertise has been brought into the system for that, definitely this offshore wind is going to be a feasible solution for that. When you look at the rest of the world, China is also having a mega plan for the offshore wind. United States in the small way, but India, now we started with land and then with NIVE and then our collaboration, I think definitely we will come up with offshore wind in the future. But if you look at total installed capacity in India, 67% goes for only coal, and then whereas 20% goes for hydro, only 8% goes for the wind. I think this need to be improved in the future depending upon the technology improvement further. This is the offshore wind map which Dr. Katyala has already showed. This is from our sister institute, INCOIS, National Center for Ocean Information System. That is the starting map for that. What we do here is buoy observations which are there in the sea along with the scatterometer data has been analyzed, and then these potential maps are prepared. And in general, it more or less agrees with whatever measurement has been taken up by NIVE at several places for that. That's how we have gone for the pilot installation of offshore wind mast. I skipped this block which was already told by MNRE and NIVE, and they are the custodian of all those things. I think they are the people who allocate the block and then monitors that, and then they have a very good system of single window system for the clearance of offshore wind project for that. In fact, Dr. Katyal is the head of the offshore division in MNRE. Coming to the plant load factor, this was the standard question asked by many people. We have taken some turbines and then try to analyze what is the plant load factor which we get for offshore wind. I can show here from the capacity right from 1.5 to 5 megawatt and what is the cut-in and rated speed for that. What are the plant load factor for each and every site, Rameswaram and Kanyakumari. Since Tamil Nadu got highest potential, we analyze for Rameswaram and Kanyakumari and the Tamil Nadu. Jakav is the place in Gujarat. These things have been analyzed. Once we come with that, I think which he has already mentioned about what is the wind speed which he gets for that. Tamil Nadu, I think he has indicated somewhere around 8 meters per second is the average wind speed. But what we estimated before the data was there is around 7.5. So more or less whatever secondary data we use which agrees with that. Suppose if you see Kanyakumari, it goes up to 9. So definitely Kanyakumari offshore wind turbines is going to be more feasible for that. But of course, we do also have a construction cost slightly higher compared to the Rameswaram in Kanyakumari. But when we estimate for that, we have taken all systematic procedures of wind uncertainties in terms of measurement uncertainty, failure of future wind resources and wind shear, and also on power production losses. If you look at the bottom picture where it has been highlighted in the green, which shows the plant load factor is somewhere around 0.5. For the Kanyakumari, for the Rameswaram, it is 0.45, which clearly agrees with the Dr. Katyal's actual measurements for that. Coming to the cost, how do we work out for that? On offshore wind, superstructure we have turbine and installation, substructure foundation and installation, which is quite expensive. That is where we have to bring down our cost for that. Electrical equipment, which is already mentioned about that collection system integration and transmission, and finally development and permits and operation maintenance. If you look at the right side picture, components of a capital cost for the offshore wind, 39% goes for the turbine, and whereas 20% goes for the substructure, which can increase up to 30% depending upon the site, whereas 34% goes for the electrical equipment. This also can be cut short drastically, suppose if you have good installation techniques for that. And one of our experience with Gujarat Tower is, the material cost is only 30%, but installation cost is 70%, which clearly shows that if you bring down installation cost, definitely offshore wind is going to be a promising resource for the future. Coming to the commercial model, I think someone was asking about what has been done for that. We have taken this business model, all yellow one or magenta one, what is given for that is what has been investment is put on that, and the revenue is on the green. If you see for that, investor put something and then banker comes into the picture with the interest, you have a capital cost. Insurance is one of the players for that, and then where you have operation and maintenance cost is added to that. These are all the budget what is been put under that. Bottom you have a revenue, unit price, incentives offered by the MNRE, whether it is renewable energy certificate or generation based incentive or accelerated depreciation, which is available to the many companies. In fact, the private company interest is basically to have a carbon credit. For that they wanted to go for the offshore wind. That is the first start for the any of the wind turbine which you are going to install for that. We worked out some cost, and then leverage cost goes somewhere around 10.78 for the Rameswaram, and Kanyakumari is around 9.45. This is the crude estimate from the first level of study, but definitely it will come down in the future. I think Dr. Katyal was mentioning about 13, but I am slightly on the lower side because we have a confidence of installing it at lesser cost compared to the what has been done at other places for that. Coming to the offshore wind mast, which is already showed, we can have a tower-based or LiDAR which is installed on the top. Now on the right-hand side picture shows which was designed by us, NIOT, with my team, that bottom tower and then top platform for that. This shows the LiDAR-based tower proposed to be installed at Gujarat. We have a long pile, and then top we have a circle of 5 meters dia, where we'll put solar panel and then LiDAR on the top, which measures the wind up to 125 meters height from the surface. Along with that, we also measure oceanographic data, which is below the seabed, so that becomes a viability. And if you want to do any commercial viability analysis further, this data is very useful for that. Why we require this to be done is, any financer, if you want to finance for that, they requires at least 2 years wind data to be measured. That's how this platform is required for that. Now NIVE is at that place. Actually, we are working closely with NIVE and as well as with Sujlan on both the places. Sujlan is installing their own turbine in Gulf of Kutch, whereas NIVE is installing in Gulf of Kambat. Coming to the blocks, They have an ambitious plan of installation of these towers in both Tamil Nadu and Gujarat at many places. Now, right now, we are attacking only at Gujarat, but later on it will come to the Tamil Nadu, which Dr. Katiyal has already shown on that. And then if you start seeing for the Gulf of Kutch, the proposed platform will be at Jakau, where the water depth is around 15 meters, and it is 16 kilometers from the coast. That means you have to travel almost 16 kilometers from the coast where the tower will be there. And similarly in Gulf of Kambat, it is 23 kilometers from the coast. And you can imagine what kind of challenges you have to face once you have to install the structures in the deep sea. So we have done all this exercise. Before going to that, one of the expensive proposition is you need to have a soil data within the seabed. That is also quite expensive. I think we have spent somewhere around 60 lakhs only for the soil data to be collected for that, because we need to use a huge barge which is shown on the left. It is called as the Jacob barge, which is having a length of 30 meters, which was used for doing the soil investigation, and then soil was measured, and then after the structure was designed for that. This shows the final properties of the monopile, which is having a diameter of 1.2 meters, thickness of 25 mm, and pile length is around 42.5 meters. And the diameter of the platform is also given on the bottom for that. Along with the measuring the wind, we also measure the sea surface parameters like waves, tides, currents, and all those things. These are all oceanographic parameters which is required for the design of structure. Whenever we do this kind of design of the structures in the sea, we need to analyze for the normal conditions as well as for the extreme conditions. That's where many of the offshore projects are all challenging for that. Whenever you have a cyclone, you are going to get extreme loading for that. Those things have to be designed carefully for that. That's how this data is required for that. One of the good things with this is Ministry of Earth Sciences got a very good database on the Indian coast, so that we have a better confidence on our oceans, so that the cost can be brought out significantly. This shows a picture which was already shown by Dr. Katiyal. We were also there when we were going for that. As he said, except the last picture, all those things were there. We have been assisting right from the design to environmental clearance to every part for that, for this monopile. This shows the final configuration of the monopile for measuring the wind profile, and then top you have a platform on the tops with solar panel. Everything will come. Everything is designed in-house, and this contractor is also local contractor, and this whole project cost is somewhere around 3.6 crore for the installation of entire lidar-based platform in the deep sea. On that, only 2 crores goes only for the installation, and then balance is only the material cost for that. What are the substructure components which need to be designed for offshore wind is, whenever we are there on the shallow water, we can use the foundation called gravity foundation. Simply they rest on the seabed. Once you go to the deep sea, you need to go into the seabed where the monopile comes into the picture. Once you go offshore at a water depth of more than 70 meters for that, where ONGC normally installs the platform called jacket platforms. That is where it normally installed there. And once you go into the deep sea, then you need to have floating platforms for that. That is also NIOT is having expertise, and then is being designed for that. But these are all the long-term plans. But right now what we are attacking is only up to 30 to 40 meters depth. All technology is available, and NIOT is confident with those things for that. This shows the different foundations, what need to be done for Rameswaram, because the water depth is somewhere around 5 to 20 meters. The soil condition is somewhere around sand to silt, and we have a moderate environment. This is not a severe environment. Since it is an enclosed area, the foundations preferred are gravity type or monopile. But whereas in Kanyakumari, you need to have a monopile and jacket, because you have slightly rough conditions in the sea. Jakau, it is exactly in the Gulf area where we have a strong current, tidal currents for that. Monopile is prepared for that. This shows a clearly indication all the exercise has been done by us, what kind of foundation which is required for each and every place for that. Once we have that, future, I think initial one 5 megawatt is what turbine is planning for that, and hub weight will be somewhere around 80 meters. The rotor diameter is 126 meters. Similarly, for the monopile, the water depth is around 10 meters, and these are all some of the things which are arrived based on for 5 megawatt turbine for that. Once we come that what are all the loads we need to account for the design of the structures is aerodynamic. Now technology has developed to such an extent we can design all these loads, and then turbines are also classified for that. There are no surprises on that. On wind load, we have to take it on the entire tower, that we have complete expertise within the country, and current forces on the structure, and then along with the wave, and finally the pile soils interaction. Once we drive the pile into the deep sea, you need to analyze for the pile structure for that. This shows wind velocities, how it acts on the hub, and then what is the force which is generated on the turbine for the design of structure. Everything has been done in-house, and these things are available with that. And this shows the peak load and then thrust force which is acting for the Indian conditions, not for the foreign condition. All this data is for the Indian condition for that. Coming to the substructure design, once if we are designing for the Gujarat coast, we also need to account for the earthquake loading. Those things also been done for that. That slightly changes this cost for that. Coming to the soil interaction, entire soil profile up to 30 meters below the seabed is required for analysis of the structure for that. The data need to be collected and then it has to be analyzed for the pile has to be designed for that condition for that. Once we do that, we design normally all the structures on the land. We need not have to worry about the dynamic analysis for whatever the structure which we design in the ocean, which we need to analyze for the dynamic analysis. Whenever we do dynamic analysis, the frequency of the structure and then frequency of the wave forces which should never match. So you should design in such a way they are out of the phase. Then only you don't have resonance. I think many of you are already aware about resonance. If both frequencies match together, you will get a resonance and then structure will fail. That careful analysis has also been done for the offshore structures within the for the wind. This shows how the monopile right from the 2002 to 2018 has been evolved. Lot of technological improvements have been done for that. Now there is a which clearly shows how the cost can be brought down in the offshore wind. Like someone was asking about that in long run, offshore wind is going to be feasible for that. Once your technology improves and your confidence increases, definitely your cost will come down without any difficulty. Even a classic case of solar PV, what was the cost at the beginning, what is the cost now, which shows that clearly with the improvement of the technology over a period of time, the cost will definitely come. That's why my initial inference for that is government should have incentives at the beginning stage to promote this offshore wind. Later on, automatically without incentives itself, it will become self-sustainable for that. This shows the installation. One of the major threat for the offshore wind is we don't have a good offshore vessels to take and then put it on the system. Each offshore vessel is very expensive. So we need to design a vessel for our own condition that will bring down the cost drastically. That's what NIOT is working on, design of this kind of vessels, movements and all those things. This picture shows how do we transport the monopile from the barge, lifting and launching and positioning and finally driving with the hammer. So instead of concentrating on the actual R&D, we found that since 70% cost is going only for the installation, let us concentrate more on the installation so that you can bring down the cost and then make the project viable for that. That's how this has been worked out. This shows the monopile. On the first slide is the monopile, how it looks from the German where we have visited site for that, and then transition piece where the top the turbine will be installed and bottom you have a hammer. On the left hand side what you are seeing is the offshore barge which is to carry the monopiles and then turbines to the site for that. Then coming to the gravity based foundation, bottom if you start looking at for that, whenever you take a gravity bound foundation in the sea, you have to analyze like a ship all the motions of the foundations which should not sink for that. That requires a careful analysis. All the analysis has been done, and then finally, especially for the Rameswaram, you are envisaging only gravitation foundation. Once you do the gravitation foundation, gravity based foundation, then you will get the cost almost 50% of what has been done for other place. Here the bottom one which shows for that. If a monopile costs somewhere around 7.8 crores, the gravity based foundation will cost only 4.3 crores, which shows 50% reduction in the cost, suppose if you adopt a suitable foundation for that. This is where you need to do a lot of R&D on that. The pictures were also shown how we put it on the ramp and then lift it and then sliding into the sea and finally launching in place for that. These are some of the capabilities of NIOT, what has been done for the offshore. And we have a complete numerical modeling tools and expertise for the field to launch everything. And this shows how the loading on the monopile has been analyzed using a numerical tank called you generate everything from the numerical simulation and then the load on the pile is estimated for that. If you don't have this kind of information with you, you design a conservative design and then that definitely the cost is going to be higher for that. So that expertise is required within the country to optimize the cost for that. Similarly, piles, whatever ONGC is designing, they have a jacket length of only 2 meters dia large. That cannot be straight away applied to the offshore wind. You need to have your own design to be analyzed for that. That has been done by NIOT. Bottom graphs which can clearly from there up to 3 meters, whatever ONGC designs are there for the APA standards, that can be applied for that. But once the diameter increases, we have a large deviation in the system, in the design. that need to be accounted for the design of structures for that. Actually, this is the video what we have designed for the island. Someone was talking about the island for the desalination plant. Normally, it is supposed to cost somewhere around 30 to 40 crores, but we did everything in 15 crores using a local technology and then on-site design for the desalination plant. Similar thing can be adopted for the offshore wind. This is the what wave we get it in the islands. These all the structures need to be analyzed for that. This everything design installation are done in-house by NIOT, not from any international consultant for that. This is the wave loading there for that. This is a bridge to draw the pipeline. This is the concrete caisson of 12 meters by 8. You may be surprised to know this was floated in the water like a ship and taken to other side for that. That's how it was cast in the lagoon and pushed into the lagoon slowly without any heavy equipment. Now it is floated there. The entire technique is only a simple principle of Archimedes, which was taken, and then 15 kilometers in the deep sea it was taken with a simple boat, tugboat of, you can see here it is floating there. It is a concrete one, not wooden one, which is having a weight of somewhere around 500 tons. What happened? Finally, this caisson was brought to the site and then lowered using water filled into that. This shows how the structures have been built within the sea. This is a sequence of construction activities which were done for these caissons. Why I am showing this video is, if you don't see this video, you don't understand from the other place. Always the techniques which are used in other place, they are quite expensive. But if you adapt your own techniques within Indian conditions, that cost can be brought down subsequently. These are all launched using only simple rollers onto the desalination plant. The intake structure which was there in the deep sea is somewhere around 6 meters water depth, and all the equipment were installed without much heavy crane. There are no cranes in that, simple chain pulley blocks were used and then lowered it for that. Even the pipeline, which is very much similar to the laying of submarine cables for the evacuation, NIOT got all this expertise. Everything was done in-house and then floated and then taken to the site. This laying of submarine pipeline at water depth of 350 meters into the deep sea. This is underwater positioning, keeping the blocks on the top to force against the currents. These are all trained divers by NIOT to fix the underwater installations. That's how it has been done for the island, and same thing can be applied for the offshore wind, which definitely brings down the cost. We also have expertise for the offshore to installation of some of the foundations, everything for that. So we have a long plan to build such kind of facilities within the Ministry of Earth Sciences called offshore numerical tank. This hydrodynamic simulator laboratory will be there, which can simulate the ocean conditions in the laboratory, in the visualized room. You can see on the bottom like a real-time simulator, like a flight simulator and all those things. You can have everything within the controlled condition, and then we have a big physical basin facility to test all the offshore installation. Such kind of capabilities were available within the Ministry of Earth Sciences. This shows once we wanted to have a loading, how the wave comes and then hits on the structure. Then you go and analyze the loading on the any structure which is there in the deep sea. Then come to the ship motions, which we analyze for the floating structures. Then finally the mooring of the ships are for the floating structures. Then finally all these things are analyzed completely in a non-linear way, so that all uncertainties are seen before design of the structure. And then finally this is the facility of a ministry at a cost of 600 crores. We don't know when the government will give the money. Once if it comes for that, on the offshore part, we will be self-sustainable. We need not have to depend on any of the foreign countries. Right now, any testing which has to be done for offshore, ONGC goes to the other countries. Each and every testing is somewhere around 2 crores. If we build this facility within the country, this cost can be cut down and then in-house expertise is developed for that. To conclude my section, I think we know very well for that fossil fuels, if you want to reduce, the only alternative is renewable energy. India has abundant renewable energy sources which can contribute to a reduction on the dependency on the fossil fuels. R&D activities in the wind energy technologies for last 2 decades have improved significantly, which reduces the production prices on par with the conventional sources of energy. Government interventions in offshore wind energy sector can ensure commercial viability of these projects, which Dr. Katyal was already mentioning about that. Initially we may require incentives, but later on you don't require anything. Automatically the project itself will take care of that. And then commercial viability studies for Rameswaram and Kanyakumari shows a promising results for that, which is supported by the NIVE data. Coming to the actual implementation of offshore block, MNRE, I think NIVE is the agency which coordinates for the offshore blocks, and then which Katyal has already showed for that. One of the important key components for offshore wind development is identification of suitable wind turbine technology, which NIVE is having a very good expertise on that. Grid connectivity and laying of submarine cables. Grid connectivity, they are the experts, and then laying of submarine cables, NIOT can take up for that. Seabed characteristics and ocean climate, we have many institutes within the country like NIOT and then NIO, they can take up that work and then do for that. Substructure concepts have already been designed and the installation methodologies were already been arrived by NIOT. Vessel requirement and port infrastructure for that, we also work parallelly on that to have a proper vessel for Indian conditions for that. Without depending on the Singapore or other Korea vessels for that, we can have our own vessels modified for that. That is the first classic case of offshore monopile, where this vessel has been structured for the monopile and then all the fittings were made within the vessel for the installation. Involvement of industry right from the stage of pilot project. That's what we are getting involved with the Sujlan in supporting all these things. We closely work with Sujlan and development of strong R&D base for cost optimization, whether it is on turbine or even in the installation for that. On offshore part, you need to worry more about the installation, which I already showed from there. And finally, I thank these organizers and then SV University and team, MNRE and NIVE, especially Dr. Katyal. He was there with me from the beginning of this project, Secretary MOS and then Director and then my colleagues who have been contributed for that. Thanks for contribution.